Hi everyone, and we're going to continue our discussion on meteorology. And this time we're going to look at a different part of a weather map that we haven't looked at yet. It's those red and blue lines with the symbols along them that are called a front. Now, a front is an interface or a boundary between two air masses. It actually is the front of an air mass. Conditions at the front are usually unstable and associated with precipitation. Now, there are four types of fronts that we're going to be responsible for in this course. So we need to open the reference table to page 13. You'll see right next to the air masses box is a front box, and it goes through each symbol. A cold front is the one with the triangles on it, like icicles. The warm front is with the half circles, or like suns. Stationary has cold on one side and warm on the other. And occluded has circle, then triangle, then half circle, then triangle, then half circle, in a pattern all along the same side of the line. So we're going to go through each of these symbols and the fronts right now. Cold fronts. As I said, cold front is a front of a cold air mass, so it would be a polar air mass. And you see the way the triangles or icicles are pointing. Now this is pertinent. The points face the direction that it's moving. So you can see here that because the triangles are on this side of the line, it means that this air mass is moving in this direction. And because it's a front, all of the cold air is behind it. So let's get these notes down. Cold air moves into an area that was occupied by warm air. Now remember, we said fronts are boundaries between two air masses. So when we talk about the cold air mass that the front is leading the way for, we also need to talk about the warm air mass that it's taking the place of. So the warm air is ahead of the front. The cold air moves in and occupies that same space. Now the cold, dense air pushes against and under the warm air, forcing the warm air to rise. And every time we have warm air rising, we get clouds. Now in this case, we get really big cumulus clouds, cumulonimbus clouds, and they're forceful because the air is being forced up. So it's precipitation is usually occurring, thunderstorms. Wind speed will increase, air pressure will drop. Okay, so let's make sure that we take note of all of these occurrences that are associated with cold fronts. Now this is a diagram of the side view, and you do need to copy this down. What you should note is the ground right along here, and you have a line. If you've printed out the notes, you have a line in your notes. You are to make this rounded shape, and you write cold front, and you're going to make an arrow pointing that way to indicate that the cold front is moving in that direction. Okay? In addition, you're going to make the big cumulus nimbus clouds that form by that warm air rising forcefully in front of the cold front. And we have rain and thunderstorms. So if you want to make a lightning bolt coming out of there, you can. Here's another side view, and this demonstrates the movement of the air. You see the cold air coming in from this way, from this direction, and the warm air being forced upwards. And there's the thunderbolt, the lightning bolt that I was telling you about. The warm air is forced upwards so quickly that it creates thunderstorms. Now, as I mentioned before, temperatures are cooler behind the cold front, and dry, warmer air is ahead of the cold front. Warm fronts. Warm fronts are symbolized by those round half circles like suns. And a warm air mass will move into an area that's already being occupied by cool air. The warmer, less dense air will move on top of the cold air mass. And the warm air, as it moves on top, will rise, expand, cool to the dew point, condense, and form clouds. Now these clouds are usually stratus clouds. They're the long stringy clouds that are looking like a cotton ball. The air pressure falls, precipitation will follow, and it will last longer because it's a gentle, gradual rise of the air. It doesn't rise fast and forcefully like it would in the cold front. Let's look at the side view. In the next slide, we'll look at the side view. But as I said before, the temperatures are warmer behind the front, behind a warm front, and cooler air will be ahead of the front. Just as we saw the cold front had the cold air behind it, the warm front has the warm air behind it. Here's that slide of the side view that I was mentioning. So what you see here is the warm air is coming in from over this way, and it's sliding up gradually, rising because it's less dense, over the cold air that's ahead of it. And in this instance, it will create those long, drawn-out, stringy clouds known as stratus clouds, and rain will last for several days in a warm front. Moving on to stationary front, we have a cold air mass and a warm air mass colliding in the same space. So we have warm coming from one side, cold from the other, and it just gets into almost like a tug of war struggle where the movement doesn't go much from one area to the other. The warm air doesn't dominate, the cold air doesn't dominate. So a stationary front, because the word stationary means in place, these two boundaries, these two air masses will stay in that one place for a few days. So the air and the precipitation will last for a few days with the stationary front. And that's why also you see the warm front symbols on one side of the line and the icicles or the triangles for the cold front on the other side of the line. And that indicates the direction that the cold front was moving and that the warm front was moving when they reacted with one another. And this is a picture of that happening. You see the cold front coming in from over here, and it's meeting with a warm front, and it just brings those clouds up, and it lingers. Now we have what's called an occluded front as the last front that we're going to talk about. And this is when faster moving cold front overtakes a slower moving warm front. The warm front gets caught between the two cold fronts, and the widespread rain and thunderstorms are generated because that warm air again is being forced upwards with that cold front, the two cold fronts, but it gets stuck there. So we do see a lot of thunderstorms and rain over a long period of time. So this diagram shows more of what I was talking about from a side view. Okay, so we have the cold front right along here with that rounded edge overtaking a warm front that's represented by this slanted line. And when that happens, it gives us the cold and the warm front symbols all along the same line. That's an occluded front. Now this brings us to a phenomenon that we experience in America because of our location in the earth. We're what's considered to be mid-latitude. And when we have this because of our planetary wind belt that we're in, we tend to get what's known as a mid-latitude cyclone. Now a cyclone begins when cold air pushes from the north and it changes a stationary front into a separate cold and warm front. So actually what was once together, the stationary front, remember, has the cold on one side, warm on the other. It almost, because there's another cold air being forced here, it almost breaks apart the two, warm front and cold front. And then results in a circular pattern because of our planetary winds and our rotation. It continues on to spiral. So the fast-moving cold front comes from the north and pushes that warm air, and it separates. The warm air gets sandwiched between the cold fronts. It's then lifted off of the ground, and it creates this mid-latitude cyclone. Precipitation will occur right along the frontal boundaries of this mid-latitude cyclone. So that ends our discussion on meteorology, air masses and air fronts. I will see you next time. Make sure you get all those diagrams down and the notes. Thanks.